Hello, my dear students. In this video, we will be talking about writing proofs using the axiomatic structure, which was taken from the module titled Writing a Proof by Jocelyn Q. Gamad. So at the end of this video, you are expected to illustrate the need for an axiomatic structure of a mathematical system in general and in geometry in particular. A. Defined terms. B. Undefined terms. C. Postulates. And D. Theorems. But before that, let's explore first. Find the missing number in the following. If 23 plus 1 equals 4, 46 plus 5 equals 5, 87 plus 3 equals 12, 72 plus 3 equals 6, then what is 86 plus 7? Can you decode the answer from the given conditions? Nice to hear that. What do you need to be able to figure out the answer? All right, you have to use inductive reasoning by finding the pattern. Now, what is the value of the question mark? Very good. The correct answer is 7. Now, how did you get 7? You're right. The pattern is when you get the sum of the digits of the two-digit addend, it should be equal to the sum of the one-digit addend and the sum. In here, we have 2 plus 3, that's 5. It is equal to the sum of 1 plus 4. 4 plus 6, that's 10. It's equal to adding 5 plus 5. 8 plus 7 is 15. And that is equal to 3 plus 12. And 7 plus 2, that's 9, which is also the sum of 3 and 6. So in here, we have 8 plus 6, that's 14. So what should we add to 7 to get 14? We have to add 7. Now, like this activity, many mathematical concepts are expressed as if-then statements. In geometry, for example, it is rooted in inductive and deductive reasoning, which is one tool used in proving statements. Let us recall first what is a proof. So it's a logical argument in which each statement you make is supported or justified by given information, definitions, axioms, postulates, theorems, and previously proven statements. So in this lesson, we will now be applying the different mathematical structures in geometry that we had discussed last time. We have the defined terms, the undefined terms, theorems, and postulates. But aside from those four, we can also use the different properties of equality to prove given statements. Let us recall first these properties. First, we have the addition property of equality or the APE. It states that if A equals B, then A plus C is equal to B plus C. So if you add a number to the left side of the equation, then that number should also be added to the right side of the equation. Another property is the multiplication property of equality, or also known as the MPE. It states that if A is equal to B, then AC equals BC. So given an equation, if we multiply a number to the left side of the equation, then the same number should also be multiplied to the right side of the equation. Third property, we have the substitution property of equality. If A is equal to B plus C and B equals D, then A equals D plus C. So in here, it is given that B is equal to a variable D. So from the name itself, substitution. So we can substitute D in place of B on the given equation A equals B plus C. So we now have A equals D plus C. Another property is the distributive property. It states that if A is multiplied to the sum of B and C, then it is the same as AB plus AC. It is taken by distributing the multiplier A to all the terms inside the parentheses. So we have A times B plus A times C. Another property of equality is the reflexive property, which states that given a number A, then it is equal to the same number A, or any number is equal to itself. That's why it's reflexive. Next, we have the symmetric property, which states that if A equals B, then B equals A. Or a given equation is the same as interchanging the left and right side of the equation. And the last property, we have the transitive property, which states that if A equals B and B equals C, then A equals C. So it's like the substitution property. So given a value for A, that is B, but we also have a value for B, and that is C. So if we're going to substitute C in place of B on the given equation A equals B, then we have A equals C. The only difference between a substitution and a transitive property is that for substitution property, we have an equation, or we can have more terms on the given equation. But for this, it's like there are two equivalent values only. So I hope you're now ready to write proofs. Let's start with writing algebraic proof. First example, given 2x minus 5 equals 9. We have to prove that x equals 7. Now, in algebraic proofs, we have to justify each step on the solution of the given equation. So we will be showing the algebraic proofs in two columns. For the first column, we have the solution or parts of the solution. And then for the second column, we have the reasons that will justify the solution. First, of course, we have 2x minus 5 equals 9. And where did we get that? It's from the given. Second, To solve for x using the given equation, we have to get rid first of -5. And to do that, we have to add 5 to both sides of the equation. And adding 5 to both sides of the equation, we now have 2x is equal to 9 plus 5, we have 14. And the reason for that is using APE because we added 5 to both sides of the equation. Next step, we are now ready to solve for x, and that is by getting rid of the numerical coefficient of x, which is 2. So we have to divide both sides by 2 or multiply both sides of the equation by 1/2. So we have 2x divided by 2 is x, and 14 divided by 2 is 7. So our third statement is x equals 7. And the reason for that is MPE, or multiplication property of equality. Take note, in algebra, we do not have the subtraction property of equality nor the division property of equality, because the subtraction property of equality is already under the APE, and the division property of equality is already under the multiplication property of equality. Now, since we have arrived at a statement the same as what we are trying to prove, then that ends the algebraic proof. Let's have another example. Given 4 times x minus 2 equals 2x plus 2, prove that the value of x is equal to 5. So first statement, we have the given 4 times x minus 2 equals 2x plus 2. That's from the given. So for our second statement, we have to work on the parentheses first. So we have to distribute 4. So that's now 4x minus 4 times 2 is 8 is equal to 2x plus 2. What have we done? We multiplied 4 to both x and -2. And that is by the distributive property of equality. Now for our third statement, since we already have 4x minus 8 is equal to 2x plus 2, our next target will be to put all terms with variable x on one side of the equation and the constants on one side of the equation. So to do that, we have to remove 2x on the right side of the equation, and that is done by adding -2x to both sides of the equation. So we now have 4x minus 2x, that's 2x, bring down -8, is equal to 2x minus 2x, that's 0 plus 2 is equal to 2. What property did we use? Very good. It's the APE. Next step, we now have to get rid of -8, and that is done by adding 8 to both sides of the equation. So we now have 2x minus 8 plus 8. We have 2x. And for the right side, we have 2 plus 8, and that is 10. What property did we apply? Very good. We have, again, the APE. Next, last statement. We now have, next step, we now have x equals 5, which is already what we are trying to prove. And the reason for that is what? Very good. It's MPE, or the multiplication property of equality. So that's how to make algebraic proofs. Now let's proceed to writing proofs in geometry. There are three ways in writing proofs. First is using the two-column proof, or also known as the formal proof. It uses a two-column format where the first column shows the statements while the second column are the corresponding reasons of each statement, like what we did a while back. But this time, we're going to use a table with two columns from the name itself, two-column proof. One column for the statements and one column for the reasons. Let's have example. Prove that if segment AB is congruent to segment CD and segment CD is congruent to segment EF, then segment AB is congruent to segment EF. So for our proof, of course, the first statement should be taken from the given. So we have segment AB is congruent to segment CD and segment CD is congruent to segment EF. Reason for that, it's from the given. Now, what will be our second statement? From our first statement, we now have AB is equal to CD and CD is equal to EF. Can you see the difference between the first and the second statement? Yeah, you're right. For the first statement, we are comparing the segments. But for the second statement, we are now comparing the measurement of those segments. So what's the reason for that? How did we arrive at statement number 2? You're right. It's from the definition of congruent segments, which states that if two segments are congruent, then their measurements are equal. Next, we have AB is equal to EF. Look at statement number 2. How will we arrive at AB equals EF? What property is that? Very good. It's by the transitive property of equality. Because we have AB equals CD, but that CD is equal to EF. So we can just say that AB equals EF by transitive property. Now, since AB equals EF, then we can now say that segment AB is congruent to segment EF. And of course, that is from the definition of, very good, definition of congruent segments. So that is how to write proofs using the two-column proof. Again, for the first column, we have the statements. And for the second column, we have the reasons that justify the given statements. Aside from two-column proof, we may also use the paragraph form. It is the type of proof where you write a paragraph to explain why a conjecture for a given situation is true. So instead of writing the statements and reasons in a two-column table, we just have to state them using sentences and forming a paragraph. So instead of writing the statements and reasons in a two-column table, we just have now to make sentences based on the statements and reasons to form paragraph. Let us have an example. Given that angle K is an angle, prove that angle K is congruent to angle K. So using paragraph proof, we have given an angle K, taken from this, through what property justifies that the measurement of angle K is equal to the measurement of angle K. You're right. It's by reflexive property, thus justifying that angle K is congruent to angle K because of the definition of, very good, congruent angles. So our proof in paragraph form is now, given an angle K, through reflexive property, the measurement of angle K is equal to the measurement of angle K, thus justifying that angle K is congruent to angle K because of the definition of congruent angles. And last way of writing proofs is the flowchart proof. It organizes a series of statements in a logical order, starting with the given statements. Each statement, together with its justification, is written in a box. So this time, we can now easily see the flow of the proof because we will be using boxes or different shapes with the respective reasons and of course with the use of arrows. Because for flowchart proof, arrows are used to show how each statement leads to another. Because in flowchart proofs, arrows are used to show how each statement leads to another statement. Let's have an example. Using the same example as in the paragraph form, given that angle K is an angle, prove that angle K is congruent to angle K. So instead of making sentences or paragraph using the statement and reason, we now have to write those statements and reason in side boxes and use arrowheads to show the flow of the statements. So our first statement is angle K is an angle. That's from the given. Then, using that first statement, we now have measurement of angle K is equal to the measurement of angle K by the reflexive property of equality. And using that second statement, we now have angle K is congruent to angle K by the definition of congruent angles. This is an example of a simple flowchart proof. Let's have another example. Given that the measurement of angle SEP is equal to the measurement of angle TER, prove that the measurement of angle 1 is equal to the measurement of angle 3. So, for the proof, we have this first statement, measurement of angle SEP is equal to the measurement of angle TER. What's the reason for this statement? Very good. It's from the given. Now, using the given, we now have the measurement of angles SEP is equal to the measurement of angle 1 plus the measurement of angle 2. Using the figure, we have here measurement of angle SEP. So we have this angle. It's equal to the measurement of the sum of angle 1 and angle 2. What justifies the second statement? Very good. It's by the angle addition postulate. The whole angle is equal to the sum of its parts. Next, again, using angle addition postulate. What other equation can you give aside from the second statement, measurement of angle SEP is equal to the measurement of angle 1 plus the measurement of angle 2? Very good. The measurement of angle TER. For second statement, we have this one, measurement of angle SEP. So we have the measurement of angle TER. And the measurement of that angle, angle TER, is equal to the sum of the measurement of angles 2 and 3. Now, using substitution property, what will be the next statement? Take note, for this fourth statement, you have to use the three preceding statements. Look for the connections of these three statements. And note that it's substitution property. So what would it be? Very good. It's measurement of angle 1 plus the measurement of angle 2 is equal to the measurement of angle 2 plus the measurement of angle 3. So we have substituted statements number 2 and number 3 from the first statement. So measurement of angle SEP now becomes this one, and measurement of angle TER is now this one. Next, bireflexive property. Can you still remember what is reflexive property? Good to hear that. Now, what will be our fifth statement if we're going to use reflexive property based on statement number 4? You're right. We have the measurement of angle 2 is equal to the measurement of angle 2. Because from the fourth equation, we have two same values, and that's the measurement of angle 2. And for our last statement, of course, we already arrived at what we are trying to prove. And that is the measurement of angle 1 is equal to the measurement of angle 3. That is from the fourth and fifth statements. Now, what property justifies this last statement? Very good. It's subtraction property of equality. Just to clarify, for algebraic proofs, there's no such thing as subtraction property of equality. But for geometry, subtraction property of equality is well accepted because we can subtract measurements of angles or segments or geometric figures. Unlike algebra or unlike numbers, we cannot add negative measurements of geometric figures because there is no negative measurements. So that is all about the three ways in writing a proof. So before we end, always remember that in writing proofs, we have to support or justify statements by using information, definitions, axioms or postulates, theorems, properties, and previously proven statements. And there are three ways in writing proofs. First, we have the two-column proof, which consists of a column for the statements and a column for the reasons. Second is using paragraph form. And third, we have the flowchart proof. That's all. Thank you for watching. Bye-bye.